In the vast reaches of our solar system, there's a moon that has captured the imaginations of scientists and sci-fi lovers alike. It orbits the giant planet Jupiter, hidden beneath a thick layer of ice, and has the potential to host life. This moon is called Europa. Let's dive into what makes this icy world so fascinating and explore why it might be one of the most promising places to look for life beyond Earth. Europa was first observed by Italian astronomer Galileo Galilei in 1610, along with 3 other large moons of Jupiter, Io, Ganymede, and Callisto. Known as the Galilean moons, these 4 were the first objects found to orbit another planet. Galileo's discovery changed our understanding of the cosmos, showing us that Earth was not the center of all celestial orbits. Europa, in particular, has intrigued scientists with its icy shell and the possibility that it may have a vast ocean beneath. Europa's surface is unlike anything we see on Earth. It's incredibly smooth and covered in a shell of ice, stretching across the entire moon. The surface is crisscrossed with long, reddish-brown cracks called lineae, which are believed to be caused by the gravitational forces from Jupiter's massive pull. Europa's icy crust is estimated to be between 10 and 30 kilometers thick, and beneath it may lie a hidden ocean that could hold twice as much water as all of Earth's oceans combined. These lineae cracks are some of the most distinctive features, and they suggest that Europa's icy shell might be floating on a subsurface ocean that periodically breaks through the surface. These cracks are continually shifting and moving, creating fascinating geological patterns. The idea of a hidden ocean beneath Europa's ice shell is one of the most compelling aspects of this moon. Based on data collected by the Galileo spacecraft, scientists believe that this ocean exists because of the gravitational forces from Jupiter. This constant tidal flexing generates heat, which could keep Europa's ocean from freezing completely. This hidden, salty ocean could potentially be over 100 kilometers deep, providing the conditions needed for microbial or even complex life to exist. Over recent years, both the Hubble Space Telescope and other space missions have provided evidence of water vapor plumes erupting from Europa's surface. In 2012, Hubble observed what appeared to be faint plumes of water vapor, possibly escaping from cracks in the ice. These plumes are likely similar to geysers, allowing water and gases from Europa's subsurface ocean to escape into space. These findings offer hope that we might be able to directly sample Europa's ocean in the future, without even needing to drill through kilometers of ice. Scientists are now planning missions, like the upcoming Europa Clipper mission, to study these plumes in more detail, potentially answering some of our biggest questions about Europa's habitability. Europa's position within Jupiter's magnetic field makes it one of the most intense radiation environments in the solar system. Jupiter's magnetosphere traps high-energy particles, creating intense radiation belts that sweep over Europa's surface. Any spacecraft approaching Europa needs to be well shielded from this radiation, and the high levels also pose challenges for potential future human explorers. Technology advancements are essential to ensure that robotic missions can survive long enough to collect meaningful data. The thick ice shell is another challenge. While Europa's ocean lies beneath, reaching it is no small feat. Scientists are still working on ways to drill through or penetrate this crust, which may require highly advanced drilling equipment or melting probes. One of the most exciting questions about Europa is whether it could host life. On Earth, we find life in some of the most extreme environments, from hydrothermal vents on the ocean floor to icy glaciers. Similar hydrothermal vents could exist on Europa, providing the energy and chemical nutrients that life needs. Europa's ocean is also likely to be salty, which, combined with the potential for hydrothermal activity, could make it a suitable habitat for microbial life. It's unlikely that we'd find fish or complex animals, but microorganisms might thrive in the darkness, potentially evolving over billions of years. Europa's potential to host life has inspired many works of fiction and scientific speculation. In the sci-fi classic 2001, A Space Odyssey by Arthur C. Clarke, Europa is portrayed as a world teeming with life beneath its icy surface. In the sequel 2010, Odyssey 2, humans are warned not to attempt landing on Europa. This mysterious and potentially life-bearing world has continued to fascinate authors, filmmakers, and audiences, contributing to the moon's legendary status. Europa also appears in video games, movies, and even music, symbolizing the human spirit of exploration and our ongoing quest to discover new worlds. So, what's next for our exploration of Europa? NASA's Europa Clipper mission, set to launch in the mid-2020s, will be our first dedicated mission to study Europa up close. Equipped with ice-penetrating radar and instruments designed to analyze the composition of Europa's surface and atmosphere, Europa Clipper will bring us closer to understanding whether this icy moon could indeed harbor life. Europa reminds us that our solar system is full of hidden wonders. Beneath layers of ice and across billions of miles, there might be an entire ocean waiting for us to explore. Will we find life there? Only time and science will tell. Until then, Europa remains one of our most tantalizing mysteries, a moon that could hold answers to some of humanity's biggest questions.